Right. Okay, so let's show this. So strontium 90 is a radioactive material that decays according to the function A of T equals that. So they give me a formula where A0 is the initial amount present. Assume that a scientist has a sample of 500 grams of strontium 90. Okay, so they're giving me another exponential. So this time now we're shifting gears. We're from exponential growth, we're changing to exponential decay. That's what this section's about, growth and decay. What does that mean? That means if you've got some substance and you plop it down on the counter, some strontium 90, and you let it sit, after a while it starts going away into the atmosphere, right? It starts decaying. And over time, there's less. You just let it sit there, there'll be less and less and less and less and less. That's what we're talking about. We're talking about it decaying, it's going away. So, and it's doing that exponentially. Time has climbed into power, is what they're saying. So the amount of strontium is A0 e to the minus 0.0244 t. Now, what's this A0 thing? Well, it says right here, A0 is the initial amount present. Have you seen the biology, chemistry, science formulas? They use the A0, P0, something zero stuff all the time. Are you familiar with that? Are you comfortable with that? Do you know how that works? This means, what the zero means A at time 0. Whenever they put a little subscript of 0, you don't have to do anything with that 0. That's just all symbolism. But what it means, what it always means in science formulas, is the amount of whatever at time 0. In other words, initially, at the start, at time 0. That's always, just like on the last problem with the insects, it was 100 because that was the amount that started. So again, it's just the PERT. It's just PERT. This is like P. You could just say this is the same as A equals P e to the RT. Yeah, it's right, because what is this right here? It's the P. It's the original investment. It's the original whatever. In this case, the amount of strontium initially, right? Initial amount of strontium. Okay, so it's the same thing. That's why I'm just saying, just use PERT, and you'll be good. It's the same exact thing. All right, so here we go. What is the decay rate of the strontium 90? What's the decay rate? Well, this is the R, right? Remember PERT? This is the R. What's the R? Don't worry. The negative rate. See how the rate is negative? Negative rate means decay. Positive rate means growth. See the last problem? This problem right here, where we had the insects. See how this was a positive 0.06 rate? That means the insects were growing. So if your rate is positive, the thing is growing. If your rate is negative, then the number is decaying. It's going away. All right. So the negative. So we turn that into a percentage. 2.44%. Move that decimal 2 places. 2.44% is the answer to question A. That's the rate of decay. That making sense? That means every whatever, we're talking years, yeah, years, T is years here. Every year, 2.44% of that stuff goes away. So that's strontium 90, 2.4% of it goes away every year. It decays away. Question B. How much strontium 90 is left after 20 years? So 20 years of letting it sit there, how much will be left? Let's write the formula. A0 e to the minus 0.0244 t. So 20 years. Hey, do I know the A0? 500 grams is what they're starting with, right? The scientist has a sample of 500 grams, and he or she plops it down, the 500, and we're wondering 20 years later how much of that stuff's going to be left. So the A0 is 500, isn't it? That's the principal investment. This is money that's going to shrink in the bank account. It's going to decay. Is that good to there? Now, after 20 years, so I just make T 20. Just make T 20 like that. that good there? And then we just hit the buttons on our calculator. So 500 times e to the power. I'm getting 306.9. I don't know how far they want you to round. They'll tell you. So about 306 grams of that strontium is left after 20 years. A bunch of it has gone away, right? We started at 500. It came down to 306. We good? How we doing? I'm pouring on a lot of math. You still tracking with me? 20 minutes left here. We good? Questions I can answer? I'm never sure if I'm reaching you. Always giving me the poker face here. Give me a yay or nay. Let me know if I should speed up or slow down as we're going. I'll keep moving. When, question C, when will there only be 100 grams left? By the way, you don't have to do anything with the 90. The 90 is just the type of strontium. It's not, we're not going to actually do anything with that. So question C, when will only 100 grams be left? So going to use the same formula. Can I go to a fresh screen here? Same formula. So A, but I'm going to put the 500 in, right? Because the A0 is 500. And on question C, when will only 100 grams be left? So I just put the 100 in for the amount, right? Is that good? See how these are the same as the financial problems? Like that. And then I just solve for T, because they said when. You know how to solve for T. Can I go dot, dot, dot? We did that a bunch in the financial ones. Question D. What is the half-life of strontium? You heard that phrase before, the half-life of chemicals? Half-life, let me give you the definition, means how long until only half is left. Makes sense. Half-life, like what's the life of half of it? How long till half of it goes away? So if you have that strontium 90, how long will it take till half of it has decayed away? How long will that be? That's what half-life, we're going to use that a lot in the problems to come. The half-life, they'll give you the half-life, or in this case they're asking us for, the half-life of some chemical, some compound. So the half-life of the radioactive strontium 90, what is it? So let's go back to the formula again. This is part D here. A equals 500. E to the minus 0.0244 T. So what's the half-life? What am I going to plug in for what? Exactly, 250 for A. It's just like the doubling, except it's half. It's halving instead of doubling. Remember those financial problems we did a bit ago that said how long till you double your money? Well, this is how long till you have your strontium. So you just say, well, you want the amount to be half, and remember it started at 500, right? So you want to know how long till it's only 250. That's half of the start. And then you go, and then you solve. And you know what to do, right? Divide by the 500. That's 0.5. And then what do you do next? ln, because Hitler's climbed into power, and I'll go dot, 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 if that's okay. Just bring down the power and divide. Is that good? Is that okay on C and D on that one? Same as the financial problems, huh? Except this is decaying instead of growing. So we say how long till half instead of doubles. Is that good? I want to move on. There's harder ones coming, so I want to move on to those. That's okay. And there's some kind of breed of mosquito in town that's troubling and dangerous. All right, so population of colony mosquitoes obeys the law of uninhibited growth. So whenever they say that phrase, obeys the law of an uninhibited growth. The law of uninhibited growth. Whenever they say that phrase, they mean use the PERT formula. Now, if you click on the help button for Math Excel, they change the letters. I think they call it P, and they call this P0, and I think they call that K. It's the same formula. I don't want you to be confused by that. So I'm just going to keep using PERT because you're a little bit used to PERT now, and I think it'll be easier for you. But I want you to know if you click on the help button, they'll do the same thing. They'll just call A P for population. They'll call this P0 for initial population, and they'll call R K. But it's all the same stuff, huh? It doesn't matter what you call it. It's all the same format, the same formula. So I'm just going to keep going with PERT because I think that'll be easier for you. So I'll just use PERT. So whenever they say law of uninhibited growth, they mean exponential growth, like those rabbits taking off if they're not inhibited. Okay, so let's go through the problem now. So what is the size of the colony after 4 days? 4 days. So we're going to put in 4 for T, clearly. We know that much, huh? 4 days. Put the 4 in right there. For time is in days. Anything else I need to find the P and the R. Did they? No, I can't do that right now. Yeah, no, this is harder. Yeah, I will do the 4, but not yet. We're not ready yet. Let me show you how to do this. These are going to be tougher. These are two phase. I'll do this in 2 phase. First, plug in the 1,000 for P. Well, P equals 1,000. Well, let me just put it this way. First, find your R. Second, finish the problem. Those are the 2 phases I'm talking about. So let's do the first phase here. First, you take your PERT formula, and what's our goal in the first phase? Find R. So how do I do that? Well, they say there's 1,000 mosquitoes initially. So where does that go? 1,000 mosquitoes initially? That's the P, isn't it? That's like putting that money in the bank at first, putting those number of mosquitoes initially. 1,500 mosquitoes after 1 day. So that means when T is 1 day, then the amount of mosquitoes is 1,500. Right? Everybody see that? So why are they telling me about that? Well, that gives me enough information to solve for R. See, phase 1, you first got to get R before you can then actually answer the question with the 4-day thing. That'll be how I finish. So from part 1, once I now solve for R in part 1, then I'll go back, start with the PERT formula again, put in the R I found, and then I'll plug in the 4 days and finish the problem. Does that make sense? These are harder. These are in 2 phases. First phase is do the work to find R. Second phase, then go back and finish the problem. So let's solve for R. You know how to do that quite well, right? Divide by 1,000. So that's 1.5 is e to the R. And what am I going to do there to solve for R? R's climbed into power, huh? Hitler's in power, the letter's in power, so Ln on both sides. And the power comes down. So this means I have Ln, wait to here, Ln 1.5 equals R Ln E. That kind of hard to read that, huh? Let's see if I can get some more room here. So Ln 1.5 is R Ln E. I don't know if that's any better at all. But we're good to there. Ln 1.5 is R, because the R came down to the front. R Ln E. And Ln E, as you know, is just 1. So that is R right there. R is just Ln of 1.5. I would suggest you can do whatever you want, but I think it's easier to just leave it that way rather than to get some big old long decimal and keep carting that decimal along with you. So I'm just going to leave it Ln of 1.5. That's R. So that's the end of part 1. Phase 1. Find R. So I found R now. Now let's go to part 2. Same question, part 2. So first part, I found R is Ln of 1.5. Is that what it was? Yeah. R is ln of 1.5. Now, go back to the PERT formula again. And now you can put in R and the initial amount, 1,000, that's still the principal. 1,000 mosquitoes initially. The R is ln of 0.5 times T. We good to there so far?
1.5, right?
What's that?
Is it 1.5 or?
Oh, 1.5. Thank you. Thank you. Thank you, Michael. Yeah. Good to there? Everybody okay to there? So we're to here now. And it's ln of 1.5. So, what are we trying to do? Well, they're saying now for part 2, so that was from the first part, we had this, and now this is all the work of the second part that we're going to finish. And what do we do? 4 days. So put in the, right there, 4 days. So the amount will be 1,000 e to the ln 1.5 times 4. Like that. Let me do something to help make this a little easier. Remember how e and ln cancel? So these guys right here will cancel. That's why I'm telling you to leave the ln, because something nice will happen. So this will be 1,000, and when they cancel, the 1.5 drops down out of the power zone, but the 4 is still up there. The 4 was not in the ln, so he doesn't drop down. The 4 stays up in power, but the 1.5 and e to the ln cancel, so the 1.5 drops down, but the 4 is still up there. Does that make sense on that maneuver there? Y'all okay with that? So this is just easier to type into your calculator, just like that. Just type that in and you'll get the amount of mosquitoes after 4 days. Is that good? What is that number? 1,000 times 1.5 to the 4th. I'm getting 5,062.5. So I'm going to go type that in. Are we good to there? We got that first question. And then second part, how long until 70,000 mosquitoes? So if you got that copy down, I'm going to answer part 2. Fresh screen here. Okay, so how long till 70,000 mosquitoes? So I'm again going to use the PERT. It's all the PERT formula. And we know the principal is the initial amount of mosquitoes, again, 1,000. And what's the R? Keep using the R. The R does not change. That is the rate of mosquito growth. So use the R is ln 1.5, and the P, the principal amount, is 1,000. Keep using those. The initial amount of mosquitoes is 1,000, right? That's the P. And the R, we discovered from phase 1, the growth rate is ln 1.5. And now they're asking how long, that's T, how long, T equals what? How long, how much time until there's 70,000 mosquitoes? Where do I put the 70,000? That's the A, huh? You want the amount of mosquitoes to grow like money in the bank, but not quite as nice. You want the amount of mosquitoes to grow to be 70,000. Now, let's do the trick over here, guys and gals, because this will help. This is why I'm telling you this trick with the ELN thing, because these will cancel again, right? This will make it easier for us to do this problem. Remember, the 1.5 drops down, but the T stays up. Remember, only the part that's in the LN drops down. Other powers stay up. So that'll be easier to solve, to do it that way, like that. And now I need to solve for T. You know the deal. Hitler's climbed into power, right? So get rid of the 1,000 first off. And then we'll do the LN, right? So bring it over here. What's that? 70 is 1.5 to the T. And then ln both sides. So the ln of both sides, ln, and then the power comes down. So T, ln 1.5, ln 70. Last step to get the T alone, divide by the ln 1.5. Boom, boom. there we go. Whatever that number is. Here, I'll get it real quick. ln 70 divided by ln 1.5. And we get 10.478. That's t. That's how many days. So I don't know what they want you to round it to, but 10 days or 10 and a half days. Until, that's not very long, huh? 10 days, you got 70,000 mosquitoes. They went from 1,000 to 70,000 in 10 days. That's why we need insecticides, huh? Is that good? Is that making sense on that? Questions on that one? So notice it was all about getting that R, wasn't it? That rate was crucial. Finding that R, which was ln 1.5. That was absolutely crucial, which came from this information. 1,000 to 1,500 in one day. Once they showed me a growth, I was able to nail it, right? So, all right. So population of a southern city follows the exponential law. When they say that, that's just fancy talk for PERT again. All these are just PERT. All the formulas in this section are just the PERT formula. Every one of them is continuous growth. And it's always the PERT formula in this section, 5.8, always. All right, so they'll call it by different names, uninhibited growth or exponential law or whatever. If the population doubled over 14 months. All right, this is the phase. Let's just do phase one, and then we'll be done. This is the phase one, phase two thing again. How do I know? Because they're not giving me R. I've got to have R. So when R is not given, you've got to do phase one, find R yourself, and then phase two, finish the problem. So let's just do phase one and find R. Can you do that? We got 2 minutes. Let me give you one of those to try something on your own. Do something to find R there. I've underlined all the information you need. Population doubled in 14 months. That's all you need. So they're telling you the growth, how fast it grew there. Doubled in 14 months. That city's growing fast. So if it doubled in 14 months, what's the amount? 2p, right? Like doubling an investment. 14 months, that's t. By the way, see how in a minute they're going to say years? We're going to have to turn that into months. You can't change your time units, huh? It's got to all be months or all be years. It's got to be consistent. So in a minute, when they ask me about 5 years from now, I'm going to go 5 times 12 and say 60 months. Anyway, let's finish up. So I got to solve for R. So that's enough information to solve for R there, isn't it? Just divide by P on both sides. Boom, boom. 2 is ER to the 14. And so you know the drill. ln, R to the 14 drops down. So we get ln 2, R times 14, ln E. What's ln E? 1. Divide by the 14. R equals, and I would just leave it that way. I would leave it, remember I'm into leaving the R because it makes things easier later. I'll just leave it ln 2 over 14. So that's just phase one. We would then need to finish phase two and finish the rest of the question like that. So we didn't quite finish, we never do, huh? All the